Hello everyone. On this video we will be looking at trigonometric ratios and inverse functions for trigonometric functions. Alright, so first thing we're going to do is we're going to identify our sides. Okay, so this side between A and C, we're going to call that side AC. And the side between B and C, for now we're going to call that side BC. And for our hypotenuse between A and B, we're going to call that side AB. Okay, now these are the things you're going to have to notice here. Okay, so the first thing you have to notice is that side AB is opposite your 90-degree angle. Remember, AB is your hypotenuse. Okay. Second thing you're going to have to notice is about angle AC. I mean side AC rather. Is opposite your angle B. Okay, you have angle B here. AC is the opposite. Okay, third thing you're going to notice is side BC is opposite angle A. This is angle A. Angle BC is the opposite of it. Okay, also, something else we have to notice, and in this case, adjacent just means next to. Angle A is adjacent to side AC. This is angle A. See, it's right next to side AC. Now, we don't really count the hypotenuse as being an adjacent to angle A because it's the hypotenuse. And the fifth thing we're going to notice is that angle B, let me move this up a little bit, is adjacent to side BC. And again, angle B is also adjacent to the hypotenuse, but we're only looking for the side. If it's the hypotenuse, it's not considered an adjacent side. Just the legs are considered adjacent side. All right. So if you are still writing this, feel free to press pause, but make sure you have a very clear understanding. You have angle A, this is the opposite. For angle A, this is the adjacent. For angle B, this is the opposite. For angle B, this is the adjacent. Like I said, that's very important going forward. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Where we discuss the ratios. Okay, so for the ratios of the side lengths of a right triangle are called the trigonometric ratios. Okay, now there are 6 total, but we're only doing 3 on this introduction to it. Okay, so let's say we made this side A, this side B, this side C, which is our hypotenuse, and this is angle X. Okay, so we have 3 trigonometric ratios that we're starting with. We have our sine ratio, which you'll see as SIN sine. We have our cosine ratio, just COS. And we have our tangent ratio, which we'll have as TAN. Okay, now it's one really easy way to remember those particular ratios. And I'm just going to move this up. There we go. And that's to remember SOHCAHTOA. Okay, so if you remember SOHCAHTOA, going forward, remembering the rest of these will be fairly easy. Okay, so sine of angle X is equal to opposite over the hypotenuse. But for the most part, you'll see it as sine of X is equal to opposite over hypotenuse. And that's where your SOH comes from. So sine equals opposite over hypotenuse. Now we go to our cosine. Cosine of angle X equals adjacent over hypotenuse. But mostly you'll see me write it as cosine X equals adjacent over hypotenuse. That's where the ka comes in. SOHCAHTOA. So cosine equals adjacent over hypotenuse. And then you have the tangent. There we go. The tangent of angle X is equal to the opposite over the adjacent. Or you'll see it mostly written as the tangent of angle X is equal to opposite over adjacent. And that's where the TOA comes in. Tangent equals opposite over adjacent. Okay, so we're going to use these to find the value of the trig ratio when given the angle. Okay, so when you know the angle, you can use these three, or I guess you could say these three, to figure out the trigonometric ratios. All right, so to do that, you will need either a scientific calculator or a graphing calculator, depending on which one you want. Okay, so for this one, I am going to use mine, and I'm going to give you a little bit. Let me see if I can find it where you can actually see the screen without the light blaring down on it. There we go, that's better. Okay, now before you do anything, I'm going to move this in a second so you can finish writing. Before you do anything, get your calculator. You're going to hit mode. Depending on which brain you have, you want to go down to where it says angle. You see where it's flashing radians? You don't want it on radians. You want it on degrees. So whatever calculator you have, make sure you figure out how to set it to degrees. Because if it's on radians and you're plugging in degrees, you are going to keep getting the incorrect answer over and over and over, and you will not know why. And I can tell you why. Because your calculator is set to radians and not degrees. Now, if you have a radian angle, then that's perfect. But we are going to be dealing with degrees, so you want to make sure your calculator is set to degrees. I cannot tell you how many times I have seen students become so frustrated because they could not get the right answer just to find out their calculator was set incorrectly. Okay, so make sure you do that. Very, very important. All right, so if you are still writing this, of course, feel free to press pause and finish up. We're going to go ahead and start on a few examples. Okay, so what if we wanted to calculate the trigonometric ratios of the given angle and round that to the nearest hundred? Okay, so for this right triangle, you have this side of 200, 134, 148, an angle of 42 degrees. So we want to find cosine of 42 degrees. All right, for this one, we have our hypotenuse is 17, this side is 8, this side is 15. We have an angle of 28 degrees. So we want to find tangent of 28 degrees. And for this one, we have 29 for our hypotenuse, 20, and this side is 21, 44 degrees. And we want to find sine of 44 degrees. All right, let me straighten up the paper. Okay, so first thing you want to do is remember your SOHCAHTOA. Okay, so for A, you have cosine of 42 degrees. Okay, cosine is adjacent over hypotenuse. For this one, you have your 42 degrees. What's adjacent to your 42 degrees? That's your 148. Okay, what's your hypotenuse of this one? That's the one that's opposite your right angle, which is 200. Okay, so we know that cosine of 42 degrees, really any degrees, would be adjacent over hypotenuse. Okay, your adjacent is 148. Your hypotenuse is 200. Okay, so that simplifies to 37 over 50, which 37 divided by 50 is about 0.74. Okay, so let's go for B, and we're looking for a tangent of 28 degrees. Okay, so you have the tangent of 28 degrees. Remember, the tangent is the TOA. Tangent equals opposite over adjacent. So this is your 28 degrees. What's the opposite of your 28? That's your 8. So your opposite equals 8. What's your adjacent? Remember, we're not counting the hypotenuse as an adjacent. So your 28, the adjacent to 28, is the side that's 15. Okay, so tangent of 28 degrees, which is opposite over adjacent, going to equal 8 over 15, which 8 divided by 15 is approximately 0.53. And for C, what I want you to do is press pause and solve C on your own. All right, so I'm assuming you've pressed pause and you have solved C already. So let's go ahead and verify. We have sine of 44 degrees. Okay, sine is our so sine is equal to opposite over hypotenuse. Okay, so your opposite of your 44 degrees is 20. Your adjacent is 21. Remember, it's not your hypotenuse. Your adjacent is never your hypotenuse. Oh, opposite over hypotenuse does 29. That's what I'm getting mixed up. Hypotenuse equals 29. Your adjacent is 21. Hypotenuse is 29. Duh. All right, so we have sine of 44 degrees, which is the opposite over hypotenuse, which is 20 over 29. And 20 divided by 29 is approximately 0.689655, and rounded to the nearest hundred, 0.69. All right. So if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next page. Okay. So you want to find the following trig values and round to 3 decimal places. So for A, you have cosine of 38 degrees. For B, you have tangent of 6 degrees. And for C, you have sine of 75 degrees, 40 minutes. Okay, so this is where you're going to need your calculator. Okay, so if you have it there, I'll go ahead and sit it right there. Should be enough to see it. Okay, so you have cosine. Let me see if I can kind of raise it up so you can see the buttons. So you have cosine. There's 2 cosine of 38 degrees. 38 degrees. You hit the green, hit enter. You have 0.788011. Bring that down. Cosine of 38 degrees equals 0.788011, which is approximately 0.788 when we round it 3 decimal places. All right, so what I want you to do is make sure your calculator is set to degrees and it's not on radians. I want you to try B and C. So go ahead and press pause and try those 2 on your own. All right, so I'm assuming you have pressed pause and worked those out. So let's go ahead and verify your answer. Okay, so for B, we have tangent of 6 degrees. Okay, so let's go ahead, get that up there. So we have tangent of 6 degrees is 105.10514. And rounded, it's just 0.105 round it to 3 decimal places. All right, so what about C? We have sine of 75 degrees in 40 minutes. All right, now there are some calculators where you can plug in 75 degrees in 40 minutes, and it's not too hard, but if you don't have that on your calculator, we're going to go ahead and assume that you don't, instead of assuming everyone has a calculator that can do that. Okay, so what we're going to do is we have 75 degrees plus 40 minutes, so we're going to get that 40 minutes and convert it. We have 40 minutes over 1 times, remember, 60 minutes equals 1 degree. So 60 minutes equals 1 degree. And the minutes cancel out. So you have 40 times 1, or 1 times 60 degree. This actually simplifies to 2/3 degree, which if you plug 2 divided by 3, you get 0.6666, and it keeps on going and going and going, but this should be enough for what we're doing. Okay, so you have sine of 75 degrees plus 0.6666, so 75 plus 0.6666 degree, and you can just combine those two. Sine of 75.6666 degrees. All right, we go ahead and we plug that in. Sine of 75.6666 degrees. Yep, and we have 0.968872. Point 968,872. Rounded to 3 decimal places, we get 0.969. Okay, so that should be the those should be the 3 answers that you have also for those. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Which is solving for the angle. Okay, so what we've been doing so far is just solving for the ratio. But what if we want to solve for the angle? Okay, so this is where we use the inverse, and the inverse cancels out the trig ratio. Kind of like if you multiply x times x plus 1, and the x's cancel out and give you 1, same thing. So, let's say you have sine of some angle x equals some value that we'll call y. We don't know what the number is, we'll just call it y. So what we're going to do is we're going to apply sine inverse to both sides. So this is sine inverse. Okay, so if we have sine inverse of sine of angle x equals sine inverse of y. So we applied sine inverse to this side and sine inverse to this side. Okay, the sine and the sine inverse cancel each other out. So you have angle x equals sine inverse of y. What about cosine? Same thing. But if you have cosine of some angle x equals some value that we'll call y, you apply cosine inverse to both sides. Okay, so that gives us cosine inverse of the cosine of angle x equals the cosine inverse of y. Okay, again, the cosine inverse and cosine cancel each other out. So you get angle x equals the cosine inverse of whatever your y value is. Okay. So what about tangent? Let's say tangent of angle x equals some value y. We're going to apply tangent inverse to both sides. Okay, so that gives us tangent inverse of the tangent of angle x equals the tangent inverse of y, where the tangent and tangent inverse cancel each other out. So you have angle x equals the tangent inverse of y. Okay, so that's how you will apply your inverse functions or inverse trig functions. All right, so if you are still writing, feel free to press pause and finish up. We're going to go ahead and move to the next page and start on a few examples. All right, so we want to find the acute angle x round to the nearest minute. Okay, so we have cosine x equals 0.719. We have sine of x equals 0.077. And tangent x equals 0.404. Okay, so for A, you have cosine of x equals 0.719. So we want to solve for our angle x, so we apply cosine inverse to both sides. Okay, so what does that do? That gives us cosine inverse of cosine of x equals cosine inverse of 0.719. Cosine inverse and cosine cancel each other out. So you're left with just the x equals cosine inverse of 0.719. Okay, and that you plug into your calculator. You put that here, so you have cosine inverse of 0.719. Move that over, you can see the answer. 44.028 degrees. Okay, so we know our angle x is approximately equal to 44.028 degrees. Okay, but we need our answer rounded to the nearest minute. So that 0.28, you have to convert that to minutes. Okay, 0.028 degrees over 1 times, remember, 60 minutes equals 1 degree. So 1 degree equals 60 minutes. Where your degrees cancel each other out. So you have 0.028 times 60, which is 1.68 minutes, but we want to round it to the nearest minute. So this rounds up to be 2 minutes. Okay, so that 0.028 is x equals 44 degrees and 2 minutes. Because 0.028 degrees is 2 minutes. All right, so let's go ahead and move on to B. Okay, we have sine of x is equal to 0.077. So we're going to apply sine inverse to both sides. Okay, so you have sine inverse of sine of x equals sine inverse of 0.077. Okay, the sine inverse and sine cancels out. So that just leaves the x. So x equals sine inverse of 0.077. So we plug that into our calculator. And there, move that over, there you go. Okay, so sine inverse of 0.077. Okay, so that's 4.41615. Degrees. All right, but we have to get rid of that decimal. Okay, so we go ahead, I'll just move this over here since we have more room here. So 0.41615 degrees divided by 1 minute, 60 minutes is 1 degree. 1 degree equals 60 minutes, where the degree unit of measures cancels out. So 0.41615 times 60, this will give us 24.969 minutes, and that rounds to about 25 minutes. Okay, so this will become 4 degrees. Remember, it's 4 degrees plus 0.41615 degrees, so it's 4 degrees and 25 minutes because we replace this with minutes. All right. Now, what I want you to do is I want you to press pause and try C on your own. Tangent of x equals 0.404. Okay, so I want you to try to solve that one on your own. All right, so I'm assuming you've already done it, so let's go ahead and verify. So the first thing you should have done was apply tangent inverse to both sides. Okay, so you get tangent inverse of tangent of x equals tangent inverse of 0.404. Bringing that up some. Remember, the tangent and the tangent inverse cancels out. So you have x equals tangent inverse of 0.404. 404. Plug that into your calculator. Let me bring this up here. So tangent inverse of 0.404. Okay, so that's 21.9987 degrees. 21.9987 degrees. Okay, but we have to get rid of this 0.9987. We have to round it to minutes. Okay, so 0.9987 degrees over 1 times 60 minutes equals 1 degree. Okay, the degrees cancel out, so you have 0.9987 times 60, which gives you 59.922 minutes. But this rounded to the nearest minute rounds up to be about 60 minutes. Okay, so this ends up becoming 21 degrees and 60 minutes. But we can't leave it like this because 60 minutes is just 1 degree. So you have 21 degrees plus 1 degree. So it's approximately 22.0 degrees, rounded to the nearest minute. All right. So if you are still writing, of course, feel free to pause it and finish up. But let's go ahead and move on to our last example. Oops. Okay, so what I want you to do is find the acute angle x and round to the nearest tenth of a degree. So you have cosine of x equals 0.662 and tangent of x equals 0.225. So go ahead and press pause and solve this one on your own. All right, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify. Okay, so you have cosine of x equals 0.662. Apply cosine inverse to both sides. Cosine inverse cosine of x equals cosine inverse of 0.662, where the cosine inverse and cosine cancels out. So you have x equals cosine inverse of 0.662. Plug that into your calculator and you will get, or you should get, 48.5474 degrees. And round that to the nearest tenth, it's 48.5 degrees rounded. Okay. So for B, you have tangent x equals 0.225. Apply tangent inverse to both sides. So tangent inverse of tangent x equals tangent inverse of 0.225, where the tangent and tangent inverse cancel each other out. So you have x equals tangent inverse of 0.225. Plug that into your calculator and you get 12.6804 degrees. Round that to the nearest tenth, you get 12.7 degrees. All right. So hopefully this made trigonometry seemed pretty manageable. Okay. Also hope it made sense, and I will see you on the next video.